of fruits which are going to be properly labeled, like apple, orange, like this. So this does set of a data is trained to the machine, and after proper training, we are going to test this network using the test data, where I'm going to show the apple and the orange. So when I show this data to the machine, so obviously it is going to classify the given data into a proper way, like apple and the orange. So basically, the supervised learning is going to be preferred for the classification task, regression task. Okay, so these are the main two applications of the supervised learning. Supervised learning not only usually it helps in predictive maintenance, traffic forecasting, and health monitoring. The one example that I can tell you is that a classifier that can predict which is apple, which is orange, which I have shown just now. So when it comes to unsupervised learning, where we don't have any sort of labeled data, labeled data will not be available. It learns into a clusters. Unsupervised learning clusters IoT sensors data. So here I have shown the example through the diagram. We have the unlabeled data. This unlabeled data is given as a input, but whereas in the supervised learning, we have given the label data where each and every parameter of that particular data is mentioned. But when it comes to unsupervised learning, so we don't have any sort of the label data, and this label data is given to the learning algorithm, and the learning algorithm is start learning, and it is going to classify the data, that is make a proper clusters, so which are shown in the clearly in this figure. So we have this unlabeled data which is given to the unsupervised learning algorithm, which is splitted into 3 clusters based on their shapes and based on their colors. So here I can give one example is network intrusion detection. So which is a one example for the unsupervised learning. Next comes to reinforcement learning. So reinforcement learning plays very important role, and it is going to be one of the important learning method in the IoT. So reinforcement learning allows IoT system to adapt dynamically. For example, let us assume that what is so before that one, I'll tell you with the example what is meant by reinforcement
Yudha,
learning. So let us assume that we have a dog. Okay, so we are given the training to the dog to pick a ball. So when I throw that ball, automatically wherever that ball, automatically it go to that location and it bring back that ball. So when that ball was brought, automatically the owner of the dog will give some biscuit. Okay, so whenever it brings the ball, the owner will give the a biscuit, some sort of a reward. Suppose instead of bringing the ball, if it brings the sticks, automatically the owner will not going to give the biscuit, and it says that it is not a ball, it is a something like stick. So obviously there the dog will understand, okay, when I pick the ball, I am getting the reward. When I'm picking the stick, I'm not getting the reward. So similarly, in the same fashion, in the reinforcement learning, the learning is going to be done by the interaction. So reinforcement learning allows mainly the IoT systems to adopt dynamically. For example, smart thermostats adjusting the uh, room temperature, adjusting the temperatures based on the user feedback. And reinforcement algorithm plays vital role in IoT devices as the adaptive control systems. So these are the 3 algorithms that we are going to generally discuss on the machine learning. So next we talk about the feature engineering for the IoT data. So what is the major feature in the IoT data? So the major features that we have is sensor data pre-processing, noise reduction, and feature selection and the extraction. So these are the 3 major points. As the raw data is noisy, feature extraction like FFT for vibration of data or statistical measures for time series data is a crucial for ML performance. So we need to concentrate on these three features for IoT handling. So sensor data is very important, and that raw data is consistent with a huge noise, and we should make a proper algorithms to reduce the noise in the data which we have collected. And after reduction of the noise, in the data, we need to select the proper feature, and that feature has to be extracted and which can be processed further. When it comes to machine learning models, so basically we have the four models. So decision trees, SVM, KNN, and random forest. So these are the four algorithms which we are going to use in our IoT devices. And these four models are going to be used for both type of classification and regression tasks in the IoT device. Machine learning driven predictive analytics helps industries to reduce the downtime by forecasting the failures before they occur. This is very important. The predictive analytics can be done by using the machine learning. So, for example, if any failure is going to occur in the industry, if I detect the failure in advance, it can be very helpful for me to improve the production by avoiding the such breakdown in the industry. Here, I have taken some example like patient health monitoring or energy demand forecasting or maintenance scheduling. For example, if I can predict that the so and so patient is going to get heart attack after 15 days. So before 15 days only, I can start the treatment so that I can avoid that heart attack. Similarly, so in the next month, the summer is going to begin, okay, where the energy demand is more. If I start predicting such things, so if I start production, the more energy, so that can be avoided. So like this, the predictive analytics is very important and that can be handled effectively using the machine learning algorithm. So here I have taken the case study for the industry 4.0. The factories mainly uses the vibration sensors with machine learning models to predict the motor failure and saving costs and avoiding the downtime. So these vibrator sensors plays vital role, especially in the industry, which are going to reduces the downtime and it increases the overall the production of the company. And I'll go for one more case study where it involves the network security. So machine learning helps identifying the unusual traffic patterns in IoT networks to prevent the cyber attacks. So you come across nowadays every IoT device is prone to attack by the cyber attacks. So we need to avoid that cyber attack. So by analyzing the traffic in the particular network. If there is a variation in the traffic, so obviously our machine learning algorithms will given the warning, okay, and it will notify that to the user. So and so traffic is suddenly increasing. So automatically, which may be because of the cyber attacker, so which can be predicted and which can be avoided to the particular IoT devices. So this is going to be possible using the machine learning algorithm. Next comes to the deep learning algorithm. So before going to talk about the deep learning, so here I'm showing the one figure which gives the complete picture about the how this AI, ML, and deep learning are linked to each other. So what is this artificial intelligence basically? Artificial intelligence is nothing but it is mimicking the behavior pattern of humans or any other living entity. So mainly in the artificial intelligence, we are trying to mimic the behavior pattern. Next, as a part of this one, we have the machine learning. A machine learning is nothing but it's a technique by which computer can learn from data without using a complex set of different tools. it is based on the training the model based on some sort of a data set. And when it comes to deep learning, it is nothing but a technique to perform machine learning inspired by our brains of our own network of the neurons. So here, deep learning is a part of the machine learning, and machine learning is a part of the artificial intelligence. So artificial intelligence is mainly concentrate on the how to mimic the human intelligence. When it comes to machine learning is going to, it's a technique which is going to make your computer to learn, or computer or a machine to learn from the given data. And when it comes to deep learning, it is a technique to perform machine learning inspired by our brain's network. So in the brain, we have the different types of neurons. With those neurons, it is going to be it is going to be handled. So deep learning preferably is going to be used when we have the huge data and the complex data. The deep learning algorithms are preferred when we have a large set of the heterogeneous data. So as I told earlier, that is IoT devices are going to generate the huge heterogeneous data. To handle this heterogeneous data, we need the efficient deep learning algorithms. So without these deep learning algorithms, it is very difficult for us to handle such a large data. And basically, the deep learning is inspired by the human brain. So in the deep learning networks, basically we have mainly the convolution neural networks, which is going to act as the heart of it for any deep learning algorithms. The convolution neural networks are used in smart surveillance systems to detect suspicious activities. So basically, the convolution neural networks are for used for image and video recognition. So as you know that for the image processing or video processing, the convolution neural network plays very important role. So when we are going to use our IoT devices for surveillance system where we need to capture the image or a video of a particular person or a particular area, so there after capturing the data, to analyze the data, we need to process that image or video with the proper algorithm. In that area, our convolution neural networks plays very important role. And with the use of the efficient deep learning algorithms, we can predict the correct data or a correct information from the given image or a video. The next comes to the recurrent neural network. The recurrent neural network is used for analyzing the time series data. It is mainly used for the modeling of a sequential. So I'll give one example. Let us assume that I'm writing the sentence. Mera Bharat Maha. This is the sentence. So I'll write the Mera. Then next word, it is linked to the previous word. I cannot write blindly there. The next word, what I'm going to write, it should be linked with the previous word. So similarly, in the recurrent neural networks, the next data is going to be linked with the previous data. But in the convolution neural network, it is not like that. The data is going to be processed. It is going to be moved from in the forward direction only. But in the recurrent neural network, the data is going to be depend upon the previous values or the previous layer. The best example for this one is ECG monitoring or the traffic forecasting. So for example, if I want to fix the certain amount of in traffic forecasting, if I want to fix the amount of time for which the green light should be turned on, it is entirely depend upon the general traffic which is shown, which is recorded in the last few weeks in that particular road. If the traffic in that particular road is more from the last 3 to 4 weeks, for that particular passage, we are going to make our green line turn on to be for the more second. So in the recurrent networks, the deep learning algorithms is not only depends upon the present value, it is something like it also depends upon the previous value. The third model that we have in our deep learning algorithms is the autoencoder. The autoencoders mainly compress the IoT data. It detects the anomalies and support energy efficient models. So here you can see that the diagram, the autoencoders has the two parts. It is encoder, latent part, and the decoder. So basically, the autoencoders are going to be used for the dimensionality reduction of the data, and not only dimensionality reduction, it is also used for the anomaly detection in the given data. The perfect example is to detect the fault detection in a IoT sensor. The next one, we have the GANs, GANs, that is called the generative adversarial networks. So what is this generative adversarial networks? So generative adversarial networks are the networks that generates synthetic IoT data for training models when real world data are scarce. So generative adversarial networks are going to collect the data from the various data sources and it creates its own information. For example, here I can give the best example is the GAN image, GAN image. So where the GAN network is going to collect the information from all the images and it's going to create its own image. And that person, the whatever the image, the photo that is created by the GAN network is not at all realistic. It is not at all going to be exist in the any part of the world. The generative adversarial networks is going to uh, generate a synthetic IoT data. So that's why I'm using the clearly the word synthetic IoT data and which is needed for the training the model. So when you're going to give the synthetic data to a training model, so it is going to be properly trained because of the various reasons when the proper data sets are not available, the real-time world data sets are not available, we have options for going the GANs, okay, which is going to work on the synthetic IoT data. And we have the one more model which combines the both your machine learning and the deep learning models. It is going to combine the classical machine learning and deep learning, where ML is the lightweight interpretable, whereas the deep learning offers higher accuracy but requires more computational and more data. This combination of the advantages, if I combine the advantages and the disadvantages of both ML and the DL, which is going to called as the hybrid model, and this hybrid model combines the advantages of both ML and the DL. So mainly the ML is a lightweight and interpretable, whereas the DL is going to be used the high accuracy, but at the cost of high computational complexity and high data rate. So mainly the deep learning algorithms are preferred for the feature extraction part of any algorithm, and machine learning algorithms are going to be preferred for the classification. Next, here I am giving the small differences between the machine learning algorithms and the deep learning algorithms. So machine learning algorithms will work with the small data which are interpretable, whereas the deep learning algorithms require large data which is a black box. So here I'm using the word black box. So what is meant by black box? That is, I don't know what is going to happen. I don't know what is going to happen in that layer or in that algorithm. Just it is like a black box where I'm going to give the input and other side I'm going to get the output. So this is going to be there in the deep learning. And machine learning, the computational complexity is low, but whereas the deep learning computational complexity is very high. So if I see if I want to explain the same thing with an example or a figure, so here I have clearly shown that the figure. Just see here, I am giving this input to the car. The machine learning algorithms, initially, it is going to extract the feature extract the features of this car. So after extraction of these features are going to be given to the network, which is mainly works on the classification part. So it classifies those features, and after that one, it is going to predict whether the given is car or not car. So since it is a car, so it is highlighting the car with a wing symbol. But when it comes to deep learning, it uses the advanced computing and its own neural network to adopt with little or no human intervention. Whereas in the machine learning algorithms, where the human intervention is needed at the larger extent, but which is for the correcting the error. But whereas in the deep learning algorithms, we don't involve any sort of the human intervention. So you can see that these three layers, the feature extraction, the classification is going to be entirely taken care by your deep learning algorithms, and which is a completely black box. We cannot understand. So how, because it is going to be a highly computational complexity system. So it is very difficult for the user to understand this one. So that's why we have used the word the black box. So here we can consider the two case studies. The first one is how these algorithms can be implemented for the traffic IoT. So here for the traffic IoT, I can consider both your CNN and your deep learning algorithms. The CNN and LSTM are going to be used for vehicle recognition and predicting the congestion patterns. So by taking the images or by taking the videos from the cameras which are fixed at the signal points. So after getting that information, it is going to be processed through both machine learning and the deep learning algorithms. And based on that one, it is going to predict the real-time traffic congestion. And based on that one, that particular signal point is going to make a decision, and it is going to allow the vehicles in a proper way so that the traffic congestion can be controlled. So this is one application which can easily shows that how my deep learning and machine learning algorithms will help for the controlling the traffic. The another one we have is healthcare IoT. So where I'm going to continuously monitoring the ECG of the patient. Here I'm going to use my deep learning LSTM models, which can continuously analyze the ECG from the patient for heart, and if any irregularity or if any abnormal condition is detected, immediately that information is given to the doctor so that the doctor can take the proper measures so that the patient can be saved. And with this one, a real-time patient monitoring who can easily possible, where the doctor availability is nowadays is big problem. So in the rural areas where the doctor cannot reach, so in such areas, these concepts are very helpful for the rural people or remote people. The people who are in the remote areas, this IoT is making a big change in their life, where remotely the doctor can monitor the health of the patient. So here I've taken one or two case studies to explain how the IoTs are helping the human community, okay, and how my machine learning algorithms and deep learning algorithms plays a vital role for these IoT devices. Next comes to the workflow. So how the workflow is there in for machine learning or deep learning in the IoT? Mainly the workflow is divided into 5 steps. The first is data collection. The sensor which is deployed in the IoT devices is going to collect the data from the measuring parameter. So data collection is the first point. The next is the second is pre-processing. After collection of the data is going to be pre-processed. So unwanted data is going to be removed, redundant data has been removed, and the data is going to be made ready for the processing. So after pre-processing, the data is going to be given for the training of the given model. That is ML or a DL model. After training, after proper training, next is the deployment. The device that is going to be deployed, and finally it will be continuously is going to be learning. That is, after deployment, the IoT device is going to be continuously learning, and it is going to make a proper decisions based on the feedbacks that it's going to use. Next comes to very important, that is edge AI and tiny. Since the IoT devices, the size of the IoT devices are very small, I cannot go for a larger algorithms or a algorithms which is requires a huge data. Here, that's why I'm using the word tiny machine learning. This tiny machine learning is going to be small algorithms which can easily and efficiently is going to work effectively on your IoT devices. So in this figure, you can see that how these end devices are going to be connected to the edge device. So here we have the edge server. So this edge server, we have connected the devices, and this edge server is going to connect to the internet. Similarly, we have the deep learning networks and the other networks which is going to pre-process the data. Edge AI brings the machine learning or deep learning models closer to devices, reducing the latency, and it is going to dependency on the cloud connectivity. And to transfer the data, it uses the low bandwidth. So the frameworks that generally we are going to prefer is TensorFlow Lite and the Edge Impulse. Next comes to, are we need the edge or a cloud or a fog? So depending upon your requirements, so depending upon the devices, we have the three options. The edge, which is going to be a local, and it's going to be a real-time processing. When it comes to cloud, it is going to be centralized and high computation, but it is going to be slower. And fog, it is an intermediate layer bringing the edge and the cloud together. So the one more ML is that is called the tiny ML, which enables machine learning algorithms on the microcontrollers, allowing the ultra low power devices to run AI locally. Next comes to energy efficient AI. What do you mean by energy efficient AI? So here we are designing the IoT devices, and these IoT device has to be environmental friendly. The exhaust, the carbon dioxide exhaust for these devices should be minimum, and so that we have to optimize our machine learning algorithms and the deep learning models so that it can consume the minimum power. By making this minimum power utilization, we can make the efficient artificial intelligence algorithms, which is going to be called as a green AI. So green AI is not a new word. So green AI means where the models or the machine learning algorithms which we are using, which is going to improve the energy utilization, and which is going to reduce the carbon emission the minimum. So we talked about the different types of algorithms, the importance of the algorithms, all how these deep learning algorithms plays important role
in the analyzing, in the prediction, how it is making the and IoT devices environmental friendly. But when it comes to the challenges, we have the deployment challenges. So, what is this deployment challenges that we are going to come across? Generally, the deployment challenges that we are going to have is the resource constraints. The resources constraints is a very important challenge when it comes to deployment. The second one we have the scalability. The third one is we have the uh, security, and the fourth one we have the maintenance of the models. So these are the few deployment challenges that we are going to come across when we comes to the deployment part of the our IoT devices. Because here the major problem with the IoT devices is the size. The IoT devices are more compact, and we in that compact area we need to build a maximum circuit which can use the maximum output, and scalability, which is very important, that is the reduction of the size. At the same time we have to think about the security. So here we are taking one case study, smart wearables. You have seen the your digital watch, which is nowadays is not only giving the time, you can store the images, you can use that one for the communication, you can use them for the healthcare monitoring, you can use those devices for even sending the messages also. So these smart wearables is performing the many functions with the size of very small. So you can see that how what is the size of that watch. So compared to that functionality, the size is very small, and we need to provide all sort of uh, functionality through the algorithms in that watch. So here local processing of the health data is very important. So as soon as the data is received through the sensors, the data has to be processed there only, and based on that data we need to give the proper output. And after processing the data, we need to find any sort of anomalies that are there in that particular uh, data, that should be given as alerts to the end user so that they can make the proper decision. So if you go through these things, it may looks from one side, it may looks it's a very simple, but when it comes to the implementation part, the deployment part, it is a very complex. We need to take care about the each and every minute step, be bit careful that the data should not be lost. Even a small data is also very important, because it it is high important data, and that data cannot be missed by your sensors. When you have the larger data, obviously we have the security threats. So which is very important. So we need to take care about the security, how to provide the security to the data which is captured by the IoT devices. As I told in the introduction part itself, my IoT devices is capturing the huge data, and I need to protect that data from unauthorized access, data breaches, device hijacking, and DDoS attacks. So these are the few security threats that we are going to come across during our uh, analysis. That is, these security threats is going to be very serious concern as far as IoT device implementation. To make your IoT device implementation successfully, you as a user, you have to take care about these security threats, which is given by which are going to be uh, such as unauthorized access. So the data should not be accessed by any unauthorized. IoT devices are more vulnerable to these attacks due to the weak authentication and limited protocols. So how to control this one? Again, we have the again our machine learning and deep learning models which are going to be effectively handle these security breaches. So as I told earlier, that is we are facing with the weak authentication and limited security protocols in our IoT devices. I need to provide some sort of the protocol, some sort of algorithms which are going to helpful to increase the security for my devices, so like machine learning algorithms or deep learning models which are going to be used, and these algorithms are provided for anomaly based intrusion detection, for predictive security, and self learning models. So these models are going to be they are going to learn self without any external input and make the system more secure. And we have the one more advantage that we is the called the federated learning IoT. So what is this federated learning in IoT? So federated learning allows the collaborative AI without sharing the raw IoT data and improving the privacy. So here you need not to share your data. Training without centralizing the data. That concept is very important here. So you are going to train your device without considering the entire data, and at the same time we are going to preserve the privacy. So this predictive learning is going to improve the effective function of the IoT devices, and this predictive learning is going to give the maximum security which is needed for the IoT device. As security, we have seen that when it comes to security, without blockchain, without blockchain, I cannot talk about the security. So blockchain plus AI plus IoT is a great combination to provide greater uh, security for the IoT device. The blockchain techniques are going to be efficiently used to provide the proper uh, security in the IoT devices, and these blockchain techniques are going to be implemented in such a way that can be effectively run on these IoT devices. So here, when I'm talking about the IoT devices, so the space area is very important. At the same time, the power, because as these devices are very small, so the power requirement is also going to be very less. So in turn, so the algorithms which has to be using in these IoT devices has to be power optimized, not only power optimized, and it should be effectively utilize the space also. So that's why whatever the algorithms that we are going to use in IoT devices, we need to special care has to be taken. The blockchain technology offers a decentralized, secure framework for the IoT devices by acting as a distributed ledger to record and validate transactions between devices, enhancing the security, trust, and the integrity. So, what is meant by decentralized ledger? How it is going to work? So, decentralized ledger in the blockchain eliminates the need of central authority by storing the data in distributed ledger. So, here in the blockchain technologies, we are going to use the decentralized ledger. So by going for the decentralized ledgers, we are avoiding the storing the data at the center. So by doing this one, a proper data sharing is going to be provided, and by doing this one, I can protect my data efficient way. The next one is your future direction. So here, when it comes to the IoT devices. So the people who wants to do the research, especially in the IoT devices. So this is the three directions that I want to share with you people. That is 6G for the communication, AI is for the algorithms, and IoT devices. So the combination of these three is a greater uh, area, especially for the research. So where you can think about the research part, that is the 6G plus AI plus IoT. The second one is digital twins. As telecommunication technology transition from 4G to incredible promises and potential of 5G, one thing is clear, the new technology is not just an incremental upgrade, but an exponential leap in terms of speed, accuracy, latency, and complexity. A 5G digital twin is a new approach to testing, assurance, providing an emulated software replica of the 5G physical network that allows continuous prototyping, testing, assuring self-optimization of the living network. So digital twins is very helpful for the many people who can talk about the research area. The third one, we have the autonomous IoT systems. The autonomous IoT systems, so nowadays everyone is talking about the autonomous vehicles. The autonomous vehicles, so you have seen the Tesla, where without a driver, that entire Tesla vehicle is going to be controlled. So even recently I have seen the Harrier vehicle also. If you park the Harrier, Tata Harrier, so in India, why I'm taking this Tata Harrier things, because it is our Indian product. So I'm telling you because we are not seen the Tesla vehicle in real time. We have seen the videos, but I've seen really the Harrier vehicle where when I park the Harrier vehicle, okay, so if it is jammed by the other two vehicles side by side, so just by pressing the buttons, I can move the Harrier vehicles backside without driver. So automatically the uh, vehicle itself is going to make the proper decision, and based on the proper decision, it is going to coming out of that uh, location and it's going to stand to in a owner friendly area so that he can move, he can drive safely. So autonomous vehicles is playing the vital role in nowadays, and to implement these autonomous vehicles to make this system effectively, we need a autonomous IoT system. So this is the one more challenging area where the user can go for in a to an extent where the research cannot be stopped. So it will be continuous autonomous IoT system. So now we are talking about the autonomous vehicles. In the future, we are going to get the autonomous factories where the labor is not at all needed. So still, we give the input and it will give the output without any sort of the labors. Everything is going to be controlled. Everything is going to be controlled by the autonomous systems. And to implement these autonomous systems, we need a efficient IoT devices, efficient uh, algorithms, deep learning algorithms, and machine level algorithms. Because as the devices are go on increasing, so the data that is collected by these IoT devices is going to be increases exponentially. That is, we need to think about. So to yes, I'm not denying that the IoT devices are providing the great help to the mankind. But the data that is collected by these IoT devices is not small data, and it is a huge data. The introduction part also, I clearly told you that. So by the end of 2030, there will be a 1.5 trillion data, okay, that we are going to process, that we need to process. So to get the more comfort from these IoT devices, we need to handle the data effectively that are created by these devices. To handle these data, we need to handle the efficient deep learning and machine learning algorithms. The algorithms not only efficient, they has to be optimized in every parameter. That is very important. So that's why, so you can work on these autonomous IoT systems. It is going to be a greater area, especially for the young researchers who can think for implementation of the research. So autonomous IoT system is one thing. So the another set of areas which I can share with you people is lightweight DL models. As I told earlier, when it's talking about the deep learning models means clearly that it is a computationally complex models, and it involves many complex structure which cannot be easily understood by a common man. So since IoT devices are in the compact in size, so obviously the models that I'm going to loading in my IoT devices should be a lightweight. Lightweight in the sense not the weight. So the computational complexity should be reduced, but without compromising the output. So we need to invent, we need to design the models, okay, which gives us the minimum number of layers with the for giving the same set of the output. For example, if I'm getting the output for using the some 5 layers means in the lightweight deep learning models, the same output I should get by going for the 2 or 1 layer. Okay, so by doing this one, obviously the program part is going to be greatly reduced, and so when the program part is greatly reduced, so obviously the storage capacity which is needed for storing this program in the IoT device is also going to be greatly reduced. So that's why that's why so the one area is called the lightweight deep learning models. So which is presently very emerging research trends. So everyone is talking about the deep learning models and the machine learning algorithms, but these lightweight DL models are going to be greatly helpful. The next one is green AI. As I discussed earlier, we need to reduce the emission, carbon emission. So that is going to be possible with the use of the green AI technology. Green AI technologies. The third one that we have the emerging research trend is our tiny ML innovations. So machine learning algorithms, the tiny ML is also very important area. The last one we have the AIoT ecosystems. So this AIoT ecosystem, advanced IoT ecosystems are going to be very helpful, okay, to build the efficient IoT devices. So these are the 4 research trends that are there presently, and many papers are coming out. So those who are really interested to do the research, so this is another set of the research trends presently that are going in the market. So you can get the many number of papers. So in these areas, just go through this one and you can do the research, and your most of the works are going to be effectively completed, and your task is going to be easily. So almost we come to the end of our session. So here I want to share the one thing, the algorithms that we are going to use, the machine learning algorithms, deep learning algorithm, which is going to be empower our IoT device. At the same time, it should be a tiny ML, and the size, it should be a effectively used, and it's the program or the model, lightweight deep learning model that you are going to use, it should use the effective output. So that's why the machine learning and deep learning algorithms play very important role as far as these IoT devices concerned. So the major
reason for going these machine learning algorithms and deep learning algorithms for the IoT devices because of the data that we have. A huge set of data that we generated in the IoT devices, and this data, to handle these data, the normal algorithms are not going to be sufficient. How to implement the machine learning or the deep learning algorithm to handle these data. At the same time, it has to enhance the adaptability and the intelligence, which is very important. Without adaptability, it is very difficult to implement any machine learning or deep learning algorithms. The adaptability should be very good when it comes to the algorithms and at the same time, intelligence. So, as I told earlier, these are machine learning algorithms and deep learning algorithms mainly used for mimicking the human intelligence in the machine. So, so this intelligence has to be improved and it has to be enhanced by the algorithms. And the future is edge AI, tiny ML, and secure IoT. So these are the three terms which is going to be very important. And as I told earlier, so wherever you have the data, the immediate step is security concern. So you have to not to, it is your algorithm should not only process the data, it has to provide the proper security and it should avoid the unauthorized access out to the data so that the proper security to your data has to be provided, because wherever there is this famous saying, wherever you have a sugar, definitely there the ants will come. So similarly, wherever you have the huge data, and obviously the cyber attackers are automatically they'll come to that point. So we need to provide the proper security to the IoT device. As I told earlier, these small device, you can think that a watch which is you are wearing, it is looking very small, but just think about the how much data it is going to generate. It is generating a large data, and that large data, okay, that large data has to be processed by your that small watch. That is the algorithm that are there in that watch has to process mandatorily, because you should get the output. So that's why the algorithms what we are going to use, the machine learning algorithm and deep learning algorithms are to be effectively used. So actually the concept of the machine learning algorithms and deep learning algorithms comes in picture wherever you need processing of the huge data. So whenever we talk about the processing of the huge data, we have to use the machine learning and the deep learning algorithms. So that's why today we are talking about these ML and the DL algorithms for handling the smart IoT applications. Okay, so now as the comfort of the human being go on increases, okay, as the humans are addicted towards the more comfort, the complexity of the algorithms, the complexity of the devices which are providing the comfortness is going to increase. So when the complexity is increasing, obviously there will be a more breaches in the security. So every concept is interlinked together. You may see that. So why I need the ML, why I need the deep learning, why I need the security. If you go through this entire chain, it clearly tells how much importance is there each and every concept. Because firstly, if I link entire my presentation, you can see that what is the first one is your IoT device. What it is doing, this IoT device is generating the larger data. So when it is generating the larger data, so I need to process. So I need for the processing of this IoT data, I need which is a very large. So I have to go for the machine learning and the deep learning algorithms. So these deep learning algorithms and the machine learning algorithm should be a tiny algorithm. So it cannot be an algorithms which we are using the a IoT devices. The algorithm that we are going to use in the non IoT devices are not going to be so compact that compared to the IoT device, the algorithm that we are using in the IoT devices. So that's why
That's why we should be very choosy, very prompt in the selection of the algorithms. So you are using these algorithm for the processing of data. So next comes to the security concerns, which is very important. You cannot neglect the security concerns because you have the larger data. So you have to take care about the privacy of that data. So that's why all these four concepts, that is IoT devices, ML algorithms, DL algorithms, and security algorithms, all are interlinked. So that's why the people who are really interested to do researches in especially IoT devices, this is a one area where you can implement your concepts effectively. So why I'm suggesting you this one means, so because of the various AI tools that are available in the market today, which are freely available, because of the many simulation tools that are available. So the situation of the research, okay, the facilities that are available as of now, today, it was not the same situation in the last 10 years. So when we are doing the research to access the papers also it was a very difficult. But now the situation is not like that. You can effectively access the papers, not only the papers, you can simulate the your result effectively. So that's why whoever wants to go for the IoT devices, learning algorithms, the machine learning and deep learning algorithms is very best approaches for your research. So that's why my suggestion is please implement the concepts of the ML and DLs in the IoT devices, and your research is going to be a very is completed effectively, and you are going to those who are pursuing the PhDs, you can take this as a upper this one uh, topic, and you can complete your PhD PhD compared to other sections, other branches. So here I want to say that there are few areas where in especially in the EC department where the PhD is going to be completion of the PhD is going to be a little bit easy. So one such area is our ML and the DL algorithms in the IoT devices. These ML and DL algorithms, if you design a lightweight DL algorithm, so definitely you are going to achieve your requirement, you are going to fulfill your requirement. So with these words, I want to close these sessions. So we have the here I have the references. So some IoT books, IoT journals that are there at AAAS and IoT transactions that I have used. So once again, I'm giving the suggestions to the all the young researchers. So go for this area is a one of the emerging area nowadays. So you get the huge data, huge support. It can be one area where you can easily complete your PhD. These words I'm going to close this session. Thank you for patiently listening because listening to the last session and that is also on the
Your
video.
voice is somewhat low, sir.
Oh, sorry, sir. So listening to the session, that too on the last day, that too on the last session is not a easy task. So thank you for listening my session. So thank you everyone. Thank you one and all. So thank you for the organizers for giving this opportunity,
Yes,
especially
sir.
Basha sir, okay, and Imran sir for giving this opportunity. Thank you, sir. Thank you one and all.
Thank you, sir.
So any participant having the doubts, you may ask.
Sir.
So I can share the few things, okay, which can be
Okay, sir.
helpful for your for future research work.
Yes. Sir, on behalf of EC department, we extend our heartfelt thanks to you, sir, for delivering an insightful, clear communication and the effort you invested in making the session informative and impactful, sir. Thank you very
Thank
much,
you,
sir.
sir. Thank you, sir. Thank you. Thank you very much for giving this opportunity. Thank you, sir.
Dear participants, if you're having any queries, you can ask to our resource person or else you can communicate through chat box.
I'll share the PPTs to Basha sir. So definitely sir will going to share these PPTs to all the participants.
Yes, sir.
So I'll mention my mail ID and phone number also. Those who
sir.
are really interested to do the research, especially in the IoT devices, most welcome. I'll definitely help you people.
Okay, sir. We'll share, sir. We'll share in the to all the
Yes, sir.
participants, sir.
Yes, sir. Thank you, sir.
Thank you very much, sir. Dear
Thank you,
participants,
sir.
if you are having any queries, means you can ask to our resource person, sir, or else you can communicate through chat box also. Okay, sir. Sudhakar, sir. Thank you very much, sir.
Thank you, sir. Thank you, sir. Thank you very much. Thank you, everyone, sir.
Okay, sir.
Okay.
To all the participants, thank you for your active engagement and curiosity to keep the sessions lively and interactive. Your enthusiasm truly drove the spirit of this FDP. Every successful event deserves a graceful conclusion. Now it's time to formally conclude today's session. I would like to invite our FDP coordinator, P. Imran sir, to take over the next sessions. I invite P. Imran sir. Please continue the session, sir.
Okay, sir. Good evening, everyone. As we come to the conclusion of this 6 days AICTE-ATAL Online Faculty Development Program conducted by Department of Electronics and Communication Engineering, St. John's College of Engineering and Technology, Emiganur, Kurnool District, Andhra Pradesh. Coming to my personal experience, this FDP is brought very special moments for me as well as our organizing fraternity, because it is the first time our college has organized such an AICTE-ATAL faculty development program. It has been a memorable and learning-rich journey, and I feel proud to say that it has been successfully conducted with the support of so many people. First and foremost, I express my deepest gratitude to the AICTE-ATAL Academy for giving us this wonderful opportunity to host this faculty development program in our institution. I also extend my heartfelt thanks to our respected principal, Dr. K. Sudhakar sir, for his constant encouragement, vision and support, without which this FDP would not be materialized. And I also thank our head of the department, Dr. K. Suvarna ma'am. And I personally thank and I'm very much grateful to my co-coordinator, Mr. S. Mehboob Basha sir, for his continuous support for me in organizing this faculty development program.
Thank you, sir.
I'm also grateful to all the distinguished resource persons who provided their insights for this faculty development program and support with their expert sessions in various concepts like wireless communications, antennas, Internet of Things, AML, and so many emerging technologies. And it is really wonder to see some resource persons have shared their ideas in funding projects also. And I especially thank them for providing such insights in bringing such funding projects. And also a very big thanks to the faculty of Department of Electronics and Communication Engineering for their tireless teamwork that ensured the smooth conduction of this program. And most importantly, I extend my sincere appreciation to all the participants. Why? Because with nearly 200 registrations have been done and almost more than 100 participants have been attended with more enthusiasm. Actively, they interacted with the resource persons. Without all these participants, this FDP will never become a true success. Coming forward or bringing forward this valedictory session, now I invite our head of the department, Dr. K. Suvarna ma'am, to express her views.
Yes, sir. Thank you, sir. Thank you, Imran Garu. Respected Principal Dr. K. Sudhakar Garu, our distinguished resource persons, and all the bright and enthusiastic researchers, faculty members, a very good evening to one and all. As we embark on this enriching journey through the AICTE-ATAL online faculty development program, let us carry forward a spirit of a collaboration, a curiosity, and commitment that defines our academic community. This FDP is not just a platform for learning, it is a celebration of sharing the knowledge, innovations, and the seek of excellence. On behalf of the Department of Electronics and Communication Engineering, I extend my heartfelt gratitude to our respected principal, sir, for his continuous support and visionary leadership. Thank you, sir. Thank you, sir. And also thank our esteemed resource persons for sharing their time and expertise with us. Your presence improves this faculty program quality and impact. So thank you, sir. A special note of appreciation goes to our dedicated coordinators whose tireless effort and planning have made this event possible. Your enthusiasm and teamwork are truly commendable. So thank you, Imran sir, as well as Basha sir. To all the participating faculty members, thank you for joining us with such energy and eagerness. Your active involvement which surely makes this FDP a memorable and transformative experience. Let us move forward these open minds and a shared goal to empower ourselves and our students, our future shaped by innovative and integrity. Thank you once again. Thank you one and all for giving me this opportunity and wishing everyone a fruitful and inspiring FDP. Thank you one and all.
Thank you, madam.
Thank you, Imran sir.
Thank you,
Thank
ma'am.
you.
Now moving forward, I invite our leader of the program and our principal, Dr. K. Sudhakar sir, to express his valuable insights.
So, okay, thank you, Imran.
Please, sir.
So, good evening, everyone. So, really, I feel very happy. As a first time, we are organizing this particular FDP. I appreciate the Department of ECE and also coordinator Imran Khan and co-coordinator Mahabub Basha by taking so much of pain to organize this 6-day FDP. As a faculty, we know that it's a very difficult to organize the things like this, especially collection of resource persons from various industries, various institutions. It's a very, very difficult. Really, I congratulate to them. I hats up to them such that in wonderfully they organized and they made it a grand success regarding this particular FDP. So really, on behalf of SJCET, I thank all the participants who participated from external colleges, also from internal. So in future also, we are planning to have this type of FDPs, even workshops also. I request all the external participants try to participate. Definitely we'll send the information related to FDPs or workshop or some other. So try to do the same thing. Try to participate similar to this. See, attending the workshops or FDPs throughout the day or for a period of 3 hours per day means difficult. But really, I hats for all the participants for your enthusiasm as well as for your active participation during these 6 days. So finally, once again, I thank our management for giving us opportunity to organize this online FDP. Even in future also, we are planning to organize offline also, offline FDPs also. So once again, I congratulate the Department of ECE for successful completion of this FDP. So thank you for giving me this opportunity.
Thank you, sir. Thank you, sir.
Thank you, sir. Actually, without you, this would not be happened, sir. You have given constant encouragement and guidance throughout the completion of this FDP. Without your support, this would not be completed, sir.
Okay.
Now moving ahead, now I request any of the enthusiastic and actively participated participants to express their feelings or the feedback about this faculty development program. Participants, please give your feedback.
Yeah, sir, is my voice is audible?
Yes, sir.
Yeah, good evening to all. Myself, Dr. K. AICTE, HOD of AAA Department. It gives me immense pleasure to share a few reflections on this 6-day ATAL online faculty development program on integrating AI, IoT, and adaptive antennas for high performance communication systems, organized by the Department of ECE, St. John's College of Engineering and Technology. First of all, I'd like to sincerely thank the organizers, coordinators, and resource persons for conducting this program so effectively. Coming to the feedback, the FDP was very well organized with proper planning and coordination at every stage. The smooth conduct of sessions, punctuality, and timely communication reflected the commitment of the organizers. The program successfully met its objectives by covering the latest trends and research directions in AI, IoT, and adaptive antennas, which are crucial for advanced communication systems. The session was highly relevant, insightful, and well aligned with the theme. The blend of theory and practical perspectives made it meaningful and very impactful. The FDP was extremely effective in enhancing our skills and our knowledge. The research persons explained complex concepts in a simplified manner, making the learning process enjoyable. The sessions were systematically structured, logically sequenced, and maintained a smooth flow, enabling participants to grasp the subject step by step. The communication from the organizers was very excellent. Regular updates, timely instructions, and support throughout the program ensured a hassle-free experience to us, to our participants. The FDP certainly met and in many ways exceeded also our expectations. It provided exposure to new ideas, research possibilities, and teaching methodologies. On a whole, I would rate this FDP very highly for its organization, content quality, and especially in delivery. Now, about the resource persons, their knowledge and expertise in the domain was truly commendable. The clarity of communication and presentation skills ensured participants were engaged throughout. The speakers maintained a high level interaction, patiently addressing queries and encouraging discussions. Most importantly, the session content was highly relevant to the FDP theme, making the learning experience most purposeful. The overall effectiveness of the sessions was excellent, leaving us enriched with both conceptual understanding and practical insight. In conclusion, this FDP has been a wonderful learning journey to me, not only to me, to the entire participants. It not only deepened our knowledge, but also inspired us to explore the future directions in teaching and research. On behalf of all the participants, I extend my heartfelt thanks to the AICTE-ATAL Academy, the management of our college, St. John's College, our principal, sir, Dr. K. Sudhakar Garu, EC Department HOD Madam, Dr. K. Suvarna, our organizing team, Mr. P. Imran Khan, sir, and Mr. S. Mehboob Basha, sir, and well, all the resource persons for their efforts in making this program a grand success. Truly, it was so good and the content was so excellent. So that I wind up my speech and it is about my feedback. Thank you one and all.
Thank you, sir.
Good evening, sir.
Any other participant, please?
Good evening.
Good evening, sir.
This is Lingamurthy from Aditya Institute of Technology and Management, AICTE-Techali. Okay, this FDP is wonderful FDP. How to integrate the IoT with designing of antennas in adaptive nature for efficient high performance communication systems. So, first of all, I congratulate to the coordinator and his organization team to ensure the smooth communication and handle the online proceedings very effectively. and also they give the regular updates and reminders helped in keeping the participants well informed. And the time management of these sessions was an excellent manner with concluding of lectures and interactions as per the schedule only. Each day's session were well placed and balanced between the theory and the practical insights. And I also congratulate to the management of the St. John's College of Engineering and Technology to provide to provide their support, and technical arrangements were commendable. And finally, for any FDP, the resource persons are the key persons. The coming to this resource persons, they delivered highly insightful sessions, and their expertise in IoT and adaptive antennas was evident, and they managed to explain advanced concepts clearly while keeping the sessions interactive. Overall, I conclude that this FTB was highly enriching experiences in both the theoretical as well as practical aspects. Some resource persons in the some sessions, they show the hands-on experience also, so that this online FDP is very helpful to the participants to get the knowledge in the recent technologies, how we can integrating the IoT along with the AI tools, ML tools, deep learning tools in the designing of the antennas in the communication system. So from this FDP, I gained a valuable knowledge that will support my teaching as well as research activities also. So I sincerely thank to the Imran and his team and resource persons and ATAL Academy for providing this excellent FDP. Thank you on that.
Good
Thank you
afternoon,
very much.
everyone. This is Dr. P. Vikesh, Head of the CSE Department. I am delighted to share my feedback on the Faculty Development Program, Integrating AI, IoT and Adaptive Antennas for High Performance Communication Systems. The program was highly informative and very helpful for the faculty and researchers, young researchers, who will go with this for future. And most of the resource persons, such as this Dr. Nageshwar Rao sir, Kranti Kumar, Chandrababu Naik, and Dr. B. Naresh Kumar Reddy, G. Satya Reddy, so many of the resource persons are clearly explained the research trends and the current challenges in the high performance communication systems. This will be very helpful for developing the faculty and the young minds who go with this communication systems. And the overall FDP is well organized, and the coordinators are very much organized, and the timelines, everything is to be highly maintained. I am very thankful to the Department of ECE and St. John's College of Engineering and Technology organized this workshop. Thank you very much, sir.
Thank you, sir. Thank you, sir.
Good evening
Thank you,
to
sir.
all. I'm Dr. S. Anil Amrutraj, IQAC Coordinator, St. John's College of Engineering Technology. First of all, let me thank our St. John's College of Engineering Technology for conducting this 6 days online faculty development program. I sincerely appreciate the efforts of Mr. P. Imran Khan, sir, AICTE-ATAL Coordinator, St. John's College of Engineering Technology, and Basha, sir, towards the smooth and effective conduction of this faculty development program. The organizers extended their complete and strong support and effectively communicated throughout the program from day 1 to day 6. And I would like to say thanks to all the expertise speakers for their enlightened speeches. For me, especially Dr. Nageshwar Rao sir from VJIT Hyderabad, Dr. Abdul Rahim sir from MRE CW Hyderabad, and Dr. K. Sudhakar sir, MRE CW Hyderabad. This FTP helped us a lot to enhance our knowledge. And thanks to the organizing committee as well as all the expertise speakers. Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, good evening, sir. Mahesh this side. As a participant in the faculty development program organized by the St. John's College of Engineering Technology under the AICTE-ATAL initiative, I would like to express my heartfelt gratitude to everyone involved in making this learning journey both insightful and inspiring. This program has significantly contributed to my professional growth and broadened my understanding in the respective domain. I look forward to applying this knowledge gained here in further enrich my teaching and research endeavors. I sincerely thank all the resource persons for their excellent delivery of content. I would like to extend my special gratitude to Dr. P. Nageshwar Rao Garu and Dr. S. Krantikumar Garu for their impactful insights in this FDP. I am deeply thankful to the program coordinator, Mr. P. Imran Khan Garu, for his exemplary leadership, seamless coordination, and unwavering support throughout the program. His dedication has truly enhanced the overall experience for all participants. I would like also extend my sincere thanks to the principal of college, Dr. K. Sudhakar Garu, whose visionary guidance and encouragement have been instrumental in the successful execution of this program. And once again, I deeply thank to the all organizers of the FDP, especially Department of ECE of St. John's College of Engineering Technology for the wonderful FDP. Thank you, sir.
Good evening to everyone. I'm S. Mercy Swarupa from St. John's College of Engineering and Technology. I express my genuine gratitude to the entire St. John's College team for conducting FDP program. It was a nice experience to me as a part of this program, and I have gained knowledge from various expertise, and it is extremely enlightening to us. Thank you all, the expertise and organizing team. Thank you.
Thank you, ma'am. Any other participants?
Yeah, good evening, Imran sir. This is Kamlesh on this side.
Good evening, sir.
Yeah, sir. Thank you, sir. The effort you are showing for this program, continuously organizing, and also the latest IoT, Internet of Things related with the EC and all the other branches is a wonderful sessions we have undergone, and we have really enhanced our knowledge, sir. Thank you, and I hope in the future you continue like these programs, which will help us in our teaching profession, sir. Thank you.
Thank you, sir. Thank you for the feedback.
Good evening, sir. Hello.
Good evening, ma'am.
evening,
Good
sir.
evening, ma'am.
Good evening, sir. This is Rajkumari from St. John's College in CSE department, sir. On behalf of St. John's College and Engineering Technology, I thank Dr. K. Sudhakar Garu, the principal of the college, and I take this privilege to thank our coordinator, Mr. Imran Khan sir, and co-coordinator, Mr. Mahabub sir, for conducting this type of successful events. And I would like to extend my deepest appreciation to our distinguished speakers for sharing this profound insight and enriching our understanding of new technology. I thank all the speakers of your amazing work and your amazing work on behalf of participants. We are expecting more events like this, sir. Thank you. Thank you very much. Thank you, sir.
Thank you, madam. Thank you, madam.
Thank you, madam. Any other participants, please? Want to give a feedback?
May I, sir? Good
Yes,
evening,
yes,
sir.
please, sir.
Am I audible, sir?
Yes,
Sir, you are
please.
audible, sir.
Good evening, everyone. I am Dr. Siddhant Kulkarni from Mechatronics Engineering, Sanjini College of Engineering, Kopargaon. It's near Shirdi. And I found it's my privilege to share my feedback on this particular FDP. Being a teacher, sometimes it becomes difficult to stop while talking, but I will just curtail my feedback because everyone has covered all other points. Just throughout this session, what we understood is a wide spectrum of topics you tried to touch. And
Yes.
from the fundamentals of adaptive antenna till the IoT integration and all other aspects are covered. And I'm confident that the knowledge, whatever the participants have gained here, will significantly benefit even in our teaching also, research and future collaborative projects. So I extend my heartfelt gratitude to the organizers, coordinators, and just one suggestion, sir. Next time you arrange a workshop in the offline mode, we'll definitely try to come there. I will try to come to your place, sir. And
Sure, sir. Sure, sir.
the way you organize the FDP, it was really commendable, sir. Thank you very much.
Thank you very much, sir.
Any other participant want to give feedback?
Sir, good evening, sir.
Good evening, ma'am.
This is B. Amma from G. Kubey College of Engineering and Technology.
Yes,
Sir,
ma'am.
that organization, how he started, how he ended, it is very excellent, sir. But I gain more knowledge in this related to IoT and edge computing. What is the difference between the edge computing and like that? The session is very, very useful. I would like to congratulate both Imran Khan and Mahbub sir. Thank you, sir. Thank you.
Thank you, madam.
Thank you, ma'am.
Good evening, sir.
Good evening,
Good
sir.
evening, sir.
My name is Yengos Basha. I am from Hyderabad. I am working as an assistant professor. My college is located near Moinabad. Recently, 2 years back, I completed my post-graduation in St. John's College only. Now I am happy that my college is organizing ATAL-FDP in online section. Thank you for for organizing ATAL-FDP.
Thank you, sir.
So, good evening, sir.
Sir, good evening.
Sir, this is Dr. Y. Narasimha Reddy, sir, Controller of Examination from St. John's College.
Good evening, sir.
Sir, on behalf of the participants, I warmly extend my appreciable words to St. John's College of Engineering, the management and the principal, sir, who are provoked this conduction of ATAL-FDP. And undoubtedly, the efforts of Imran Khan, sir, and Mehboob Bashar is highly appreciable for conduction of this ATAL-FDP, first time in the college. And also, the efforts starting from the session 1 to the session 13 totally is undoubtedly it is highly appreciable and the efforts are uncalculated. I know it. And the efforts done by the coordinators, the college members, followed by the participants who are participated in this 6 days are highly appreciable. And I think that this type of ATAL-FDPs are more appreciable for the participants to gain the more knowledge on the new technologies. So I thank to one and all on behalf of the St. John's College of Engineering and myself also. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir. Any other participant, please? Participants, you will be having your assessment test right at 7:30 today. And that test will be live for only 30 minutes. You have to complete that test before 8 p.m. today. And that test comprises with 20 multiple choice questions. Try to attempt all. Remember, the end of this FDP is not just a conclusion, but a new beginning also. Why? Because it has to be like a stepping stone to apply your learnings, share knowledge with your peer teams and students. Why? Because we contributed meaningfully to academic and research community. My dear participants, always stay confident, stay curious, and continue this journey of lifelong learning. Your dedication throughout this faculty development is truly a strong reminder that we all are together, that we can transform challenges into opportunities and ideas into impactful innovations. Finally, as we close, I once again thank each and every participant and our beloved principal, Dr. K. Sudhakar sir, who directly or indirectly contributed to the success of this first ever 6 days AICTE-ATAL online faculty development program at our college. I thank you once again, and I wish each and every participant a very better future. Thank you.
Thank you,
Your
sir.
feedback link for session 12 and session 13 and overall feedback is available in the chat box now. It is mandatory to all the participants to fill all the 3 feedback links now. You can find the feedback links in the chat box. Please fill it fast. But remember, your assessment test will begin at 7:30 p.m. today, and that will be live only for 30 minutes. It is going to end at 7 p.m.
8.
And I will keep this meeting live for 10 more minutes. Whoever wants to fill the feedback, they fill it fast. Exactly at 7:10, I'm going to close this meeting. And you take rest for 20 minutes and start writing assessment at exactly 7:30 p.m. today.
Sir, then in that case, where you are going to share the link for test?
No, you have to log in the AICTE-ATAL portal. You have to take the assessment, sir.
Okay, sir. Understood. Yes.
You have to log into AICTE-ATAL portal only, where you applied for this FDP.
Sir, is there any technical issues arise?
But for that, my suggestion is not to write that assessment test in mobile phone. You please take the test in laptops or personal computers.
Okay, no issue. But is there any problem?
For that, I will see, sir. You please let me know.
Okay, thank you.
Mehboob sir. Hello.